Good afternoon, algebra students. Today we're going to be covering the Unit 8 activity. So let me go ahead and present my screen and we will get into that right away. Here we go. Okay. So let's go ahead and read the introduction. You see many ways to solve a quadratic equation. Let's briefly review some of the methods and when to use them. We're actually going to go over each of these as we go, but it says inspection, use when the answer can be determined just by looking at the equation. So if you could do it mentally. Square roots, use when inspection is not feasible and the equation has no x term. So it has an x squared, but no x term. Factoring, use when the factors of the equation are easy to find, so easy to factor. Completing the square, we're probably not going to use this one, but we are going to use the last one. Quadratic formula, this one, the quadratic formula you could use all the time. So anytime, even if it's factorable, even if it's square rootable, even if you can figure it out just by looking at it, you could always still use the quadratic formula. So if you have something that's complicated or doesn't factor, then you should use quadratic formula, but you can use it anytime, really. All right, next page. And you can see some of the examples of each of these. So like this one, see, I can tell what squared minus 121 gives me 0. Well, I know 11 squared is 121. So 11 squared minus 121 is 0. So x must be 11. So this one I could just look at. X equals 11 or even negative 11. So plus or minus 11 in this case. And you can see that the answer there, plus or minus 11. In this one, you would add 676 to both sides, then square root, and then you'd get plus or minus something, and then add the 1. So you add it to both sides, get this, add the 676, square root it, gives you a plus or minus. Whenever you square root both sides, you get a plus or minus a 1. Then add 1 to it, so 27 or negative 25. In this one, you could factor. You would be looking for two numbers that multiply to give me 21, but add up to give me 10. So two numbers that multiply to give me 21, but add up to 10 would be 3 and 7. So I'd factor as x plus 3, x plus 7. And what would cause those to be 0 are your answer. In this case, negative 3 and negative 7. This one, they use completing the square. Of course, we're not going to use that. You could always just use the quadratic formula. And this one, they show you how to use the quadratic formula. And that's this one here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, your a is 2, your b is 4, and your c is negative 15. And you just plug those into the equation as you go. So replace the a's with 2, replace the b's with 4, replace the c's with negative 15. Plug those into this formula, work it all out, and you get the answer. Notice the answer comes out super weird. Sometimes it does that. Sometimes it comes out really nice. Sometimes it comes out really weird. That's okay. But this one, you can't factor it or solve it in your head because, I mean, look at this answer. Okay. So we often use the quadratic equations to model real world situations. Blah, blah, blah. Okay. All right. So let's take a look at this first one here. Type the correct answer in each box. Write your answers in decimal form, round to the nearest tenth. That's the first decimal place, if necessary. Type the solutions with the smaller value in the first blank. So select and use the most direct method to solve. So let's take a look at this one. So we have 2x times x plus 1.5 equals negative 1. So 2x times x, was it plus 1.5? Yeah. Plus 1.5 equals negative 1. So when I see this, what I would do first is multiply the 2x times each of the things here. Distribute the 2x. So 2x times x is 2x squared. Now what I would suggest is whatever I write on here, you should write on your own on a separate sheet of paper or on your own whiteboard. It'll help you understand it much better. But anyway, 2x times 1.5 is plus 3x. And then we have an equals minus 1. But I'm going to add 1 to both sides of the equation. And that way it'll be a plus 1 over here and equals 0. So generally speaking, you want it to be equals 0. If we're going to use the quadratic formula or factoring, you want it to be 0 on this side. Now let's go ahead and try to factor it. So when you factor something like this, but it has an a term, you go ahead and multiply the a and the c together to get the top. So that's going to be 2 times 1, which is 2. The b goes on the bottom. So what two things multiply to give me 2, but add up to give me 3? Well, 2 times 1. Those multiply to give you 2, but add up to give you 3. Now, when you have this a in front, you have a 2 here. You take this 2x and you divide by each of the numbers we found here. So 2x divided by 2 and 2x divided by 1. Now you reduce each of these like it would be a fraction. Well, this second one doesn't reduce, but this one does. You can divide both top and bottom by 2. So that would be just plain x divided by 1. So these are our factors, this and this. So our factors would be x plus 1 times 2x plus 1. So this one's factorable, we solve by factoring. And we still have equals 0. Now what you do is you put each of these equal to 0. So once you have it like this, you put each factor equal to 0. So x plus 1 equals 0. And 2x plus 1 equals 0. Solving for x here, you would minus 1, minus 1. So that'd be x equals minus 1, negative 1. The other one, minus 1, minus 1. 2x equals negative 1. Then divide by 2 both sides to get x by itself. So x equals negative 1/2 or negative 0.5. And there you go. So negative 0.5 was one of them, and the other one was 1, negative 1. Just like that. So this one was factorable. Once you distribute everything and move everything to one side, you could factor that one easily enough. Let's try the next one. Solve this equation using the most direct method. So in this one, I would say we do the same thing. We're going to distribute the 3x times x, 3x times 6, and then move the 10 over. So much like we did this one. But I'll go over it with you as well. So we have 3x times x plus 6 equals, and was it 10 or negative 10? Negative 10, okay. So let's go ahead and distribute the 3x. So that's 3x squared. 3x times 6 is plus 18x. And let's go ahead and add 10 to both sides of the equation so that we can get plus 10 over here. Equals 0. So remember, if we're going to use the quadratic formula, which is that negative b plus or minus the square root of b squared minus 4ac all over 2a, we're using that quadratic formula. Or if we're factoring, we need to get everything over to one side and then 0 on the other side. Okay, so let's see if this thing's factorable. So 3 times 10 is 30. And we can put the 18 on the bottom. So I'm looking for two numbers that multiply to give me 30, but add up to give me 18. Well, let's think about it. So what multiplies to give me 30? So we have 6 times 5, 6 and 5, but would those add up to 18? No. What about 10 times 3? Well, those multiply to give me 30, but do those add up to 18? No. What about 15 times 2? Yeah, that gives me 30. But does that add up to 18? No. What about 30 times 1? Well, that doesn't add up to 18 either. So none of these work, right? None of these work. So maybe this thing's not factorable. And remember, if it's not factorable, you could always, always, always use the quadratic formula. So whether it's factorable or not, you could always use the quadratic formula. And that's what we're going to do here. Use the quadratic formula. So I'm going to write it to the side here so that you can remember. I'll write it over here. So it's negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. All right. Now in this case, our a is 3. So the a comes from what's in front of the x squared. So in this case, our a is 3. Our b is what's in front of the x. So our b is 18. And our c is what's at the end, the constant term. So in this case, our c, 10. All right. So now we just plug these numbers into the formula. So we're going to replace, everywhere you see an a, we're going to replace it with 3. Everywhere you see a b, we're going to replace it with 18. And the c, I'm going to replace with 10. So negative b becomes negative b is 18. So negative 18 plus or minus the square root of b squared. So that's 18 squared. You may need a calculator on hand. Minus 4 times a, which is 3, times c, which is 10. All divided by 2 times a. And again, a in our case is 3. So let's start working this out. So we have negative 18. Nothing we can really do with that right now. Plus or minus. Now again, the plus or minus part comes from the fact that there's a square root. So this really gives us both the answers in one. So the plus or minus will give us both the answers. Generally, when we solve a quadratic, usually there's going to be 2 answers. Not always, but usually it'll be 2 answers. So let's do the 18 squared. I got my calculator here. I don't know that one offhand. So 18 squared, 324. Minus 4 times 3 times 10. I do know that offhand. That's 120. Divided by 2 times 3. I know that one. That's 6. So it's going to be negative 18 plus or minus the square root of, so what's 324 minus 120? Well, that's 204. Divided by 6. Now to simplify a square root, I can show you how to do that. Basically, you would need a factor tree, and we're going to do that. So 204, and we're going to factor tree this out. So what 2 things multiply to give me 204? Well, we could say it's maybe 4 times 204 divided by 4 times 51. Okay, the 4 breaks down to 2 times 2. These are prime. They don't break down any farther. 51 does, though. It's going to be 3 times 17. Okay, now what does that allow us to do? Well, since we have a double in a square root, you can pull that out. Now, I know I'm covering a lot here, but hopefully you covered how to simplify a square root. You probably covered it quite a while ago, but if you don't remember, if there's doubles inside the square root, they can come out as singles. So we have negative 18 plus or minus, and this double 2 comes out of the square root as a single 2. And what's left, these come out, right? And you'll be left with a 3 and a 17 on the inside. Multiply those back together, that's 51. There's no doubles here because these are different things. So that just stays inside. Divided by 6. Now from here, we could simplify because we could divide all of these by 2. So this can become negative 9 plus or minus, divide this by 2, that 2 goes away, square root of 51 over, divide that by 2, that's 3. And there you go. So it comes out, sometimes it comes out really weird like this, but usually that's when it's not factorable. So when it's not factorable, you have to do it this way, pretty much, and or this is the easy way anyway. And you usually sometimes get something funky like that. So how do we write that weird answer in here? Well, we could use this equation editor. So I would say start off, we got a plus and a minus version. I don't know if they're going to have a plus and a plus and minus thing. Doesn't look like we have one of those. So we're going to write it into two different things. So the first one we'll write as a plus. So negative 9. So negative 9. Again, I'm using this fraction thing. Plus, you use the square root tool like that. 51 over 3, like that. And the other one was fraction again. Negative 9 minus the square root 51 over 3. All right, so those will be your two solutions in this case. It says use the plus or minus symbol, but there's no plus or minus symbol here, at least not that I can see. So we just use a plus and then a minus version. That's fine. Describe and justify the methods you use to solve the quadratic equations in part A and B. So you'll type something. I kind of explained it along the way, but for the first one, for A, it was factorable. So we were able to just factor it, and that made it easy. The second one is not factorable, so we use the quadratic formula. So that's what I want you to explain there. All right, question 2. Anne works for a city, park, and recreation department, Parks and Rec. She is looking for some commercial land for rezone for recreational use and has found 2 possible options. Anne's first option is a plot of land adjacent to a current park. The current park is a square, and the addition will increase the width by 200 meters and give the expanded park a total area of 166,400 square meters. This equation represents the area of the first option, where x is the side length of the current square park. So here's the equation there. Okay. Use the most direct method to solve this equation and find the side length of the current square park. Explain your reasoning for both the solving process and the solution. So they are using, it looks like, completing the square. Well, we're not going to use completing the square. We're actually just going to use the quadratic formula again. So it's much like what we did in the last problem, except these numbers are much bigger. But that's okay. It doesn't really make a difference. So it's going to be x squared plus 200x equals, and it was 166,400. So remember, when we want to solve using the quadratic formula or by factoring, we really want everything to be on one side and just 0 on the other side. So I'm going to go and subtract this 166,400 from both sides of the equation. Okay, cancels there, which gives us 0 on the right, which is what we want. We want 0 on the right. So we have x squared plus 200x minus 166,400. Okay. So again, I'm going to write the quadratic formula over here so we're reminded it's negative b. And if you don't have this thing memorized, you really should have it memorized. So negative b plus or minus the square root b squared minus 4ac, and this will come up again in algebra 2, divided by 2a. And in this case, our a is in whatever's in front of the x squared. So in our case, the a is 1, because it's like 1x squared. The b in this case is 200. And the c is negative 166,400. All right. Don't be intimidated by these large numbers. It really won't make a difference. So negative b, we're going to rewrite this. Just replace the a's with 1, the b's with 200, and the c with negative 166,400. So it's going to be negative b, so negative 200, plus or minus the square root of b squared becomes 200 squared, minus 4 times a is 1, times c, which is negative 166,400. All divided by 2 times a is 1 again. So let's start working this out. Negative 200 plus or minus the square root. 200 squared is 4,000,000, so 40,000. Plus, because negative times negative makes that positive, and it's going to be 4 times that. So 4 times 166,400 equals 665,600. All divided by 2 times 1, that's 2. So that's going to be negative 200 plus or minus the square root, and we add these together. So that's going to be 705,600. All divided by 2. I wrote this all long now. There we go. So on our calculators, we could do the square root. 705,600 square root, that's 840. So this becomes negative, I'm going to write it up here. Oop. So negative 200 plus or minus the square root of this on our calculator came out to 840. Divided by 2. So notice this came out clean, like there's no square root anymore attached. From there, what I would do is say split it into 2 answers. So the first one would be negative 200 plus 840 divided by 2. Then the other one would be negative 200 minus 840 divided by 2. So this one would be 640 divided by 2, which is 320. X equals 320. And then this one would give you negative 1,040 divided by 2, which is negative 520. So these are our answers. But unfortunately, only one of them makes sense. And that's this one, because you can't have a negative length, at least not in this case. So we can't add a negative length to the park. So this is our answer. We're adding 320 to its length. All right, so I want you to at least show some of this work, and you could use that using the equation editor, like this. Use the equation editor, and you could show some of the work. Maybe show this, maybe. Show this, show the two answers, and then explain why only this single answer works, the 320. And again, it's because you can't have a negative length. Okay. Oh, and look, this one has a plus or minus. That's nice. So you could show some of this work. Like if I'm showing this, it'd be negative 200, plus or minus, square root, and then 200 squared, and minus 4 times 1 times negative, what was it, 166400. Yeah. Divided by 2 times 1. Okay. See how nice and neat that looks? Maybe we could show this one, which this eventually comes out to negative 200, plus or minus. And this was 840, I believe. Yeah. Divided by 2. And that gave us the two answers. X equals 320. And X equals negative 520. See how nice and neat that looks. Now I want you to explain why 320 is the only reasonable answer. Okay, but again, I would suggest using this equation editor as much as you can, right? It makes it easier for you to show your work, makes it a lot easier for me to grade as well, okay? So if you can, I could definitely give you a better score if you show your work nice and neat like this. So please do that whenever you can. All right, now this is the last one. And second option is rezoning two separate plots of land. One is square and the other is triangular with an area of 32,500 square meters. For the second option, the total area would be 76,600 square meters, which can be represented by this equation, where x is the side length of the square park. Use the most direct method to solve this equation and find the side length of the square-shaped park. Explain your reasoning for both the solving process and the solution. So for this one's actually easy because you see how it has an x squared term, but it doesn't have an x term? So I'll show you how to do that. So this one was x squared plus, and it was 32,500. So whenever it doesn't have an x squared term, you actually don't need to use the quadratic formula. You still can use the quadratic formula. Quadratic formula is always an option. It'll always work. But you don't have to in every case. And if you don't have an x term, you just have an x squared term and constant, and it's constant over here as well, then you could just solve it like I'll show you here. So let's go ahead and get the x squared by itself. So I'm going to go ahead and subtract the 32,500 from both sides of the equation. Get rid of that, minus 32,500. We can do that in our head. 0 minus 0 is 0. 0 minus 0 is 0. 6 minus 5 is 1. 6 minus 2 is 4. 7 minus 3 is 4. Okay? And then we have x squared still on this side. Now to get rid of the squared, you simply square root. So that'll give us the square and the square root cancel. But if we add a square root to both sides like this, the other side gets a plus or minus. So that, let's keep that in mind, that the other side gets a plus or minus whenever you square root both sides like that. Now in our calculators, we could do the square root of this. So 44100, and let's square root that. 210. So our answers are x equals 210 and negative 210. So from here, which of these answers even makes sense? Well, only the positive one does, right? Negative one doesn't make any sense because you can't have a negative side length. So our answer is this. And again, show some of the work. Show some of the work right here in the equation editor and for full credit. And explain that why this is the only reasonable solution, this one. Although this solution came out in the math, it doesn't make sense in the context of this real world problem. Okay, so anyway, go ahead and put that, and that's it. That's it for this one. Okay, cool. Well, I hope that all made sense and everything. If you still need help, still confused, that's fine. Feel free to email me if you have any questions. Again, my email is ttrigg@ofy.org. That's ttrigg@ofy.org. All right. Well, with that being said, I will see you guys next time.